Here I go. Okay, so what I'm going to do is I'm going to talk to you about exam number 3. Okay, and this is the practice test for it. So, um, and I need to give you the heads up. The chart that I actually emailed you is the wrong chart. I actually emailed you the chart that goes with your final exam, but we'll talk about that in a few minutes. Okay. All right. So the first thing says using figure 1. 5,550 grams equals how many kilograms? Okay. Look, about 3 weeks ago or so, we talked about when we're doing something called conversions. Okay. And this is when we are converting one unit of measurement to another one. Okay. So it says 5,550 grams equals how many kilograms? This kg is kilograms. Now, my chart, this particular chart, is right for this question. So I'm going to turn to the chart and show you where I got this. So I'm going to look at grams and kilograms. Here's the chart that actually you'll have this on your exam next for exam number 3. Okay, so I'm kind of looking. Okay, this one's feet and inches. This one's centimeters. This one here millimeters. Oh, gee, grams, and here's got kilograms and grams. Oh, this is the one I was looking for right here. Okay, because this is what this chart is telling me, that 1 kilogram equals 1,000 grams. Okay, one of these is 1,000 grams. So that means a kilogram is bigger, okay, because it equals 1,000, okay, of the grams. So the grams are smaller. So if I go to my question, it asks me 5,500 grams, okay, equals how many kilograms? We're going from the smaller, this is the grams, okay, they're all on this side, to the larger. They're asking equals how many kilograms. This is my larger one. So I taught you that you can use this chart, okay, and it's in your notes, but when you're going from smaller to larger, you always divide. And that was the rule we put in our notes. In fact, I think I might have wrote it like this, okay, that you're always dividing. So I'm keeping all my grams on this side. I have 5,500 grams, and they want to know how many kilograms that equals. So if I try like this, how many of these kilograms is that? Okay. We just looked at our chart. We looked at this chart right here. And this chart told us that 1 kilogram is 1,000 grams. So on the chart, keeping my grams on the same side, okay, grams on this side, kilograms over there, 1,000 of these equals 1 of these, okay? This is now my chart here. If I kind of box it in here so you kind of recognize what I made it look like. It kind of looked like this in your notes. Okay. All right. And we're supposed to divide, it says. Well, we can't divide this. We can never work with the one. We divide these two things. Okay. So 5,500 divided by 1,000 equals 5.5 kilograms. There's my answer. Okay. I converted grams to kilograms. All right. Now, the good thing is, if you're going, oh, I'm nervous about getting all this down, you have this page with the answers. Okay, and you have these notes here in your email that I sent you on Monday. So you have this document, all of you do, okay, as a practice exam. I wanted you to see the same kind of questions you're going to get on the test, and I wanted you to see sample how to calculate it out, okay? All right, here's another example using figure 1, convert 17 meters. So I got meters to centimeters. They want to know to how many centimeters. Well, meters are larger, okay, centimeters are smaller. We're converting the meters, the larger thing, this is my m's, okay, I'll put an m next to it, okay, in parentheses, to something that's smaller, centimeters. And this is my centimeters, put that in parentheses. So whenever you are doing that, I put this little note here for you guys. When you're going from larger to smaller, you're going to multiply, okay? So if you kind of put this in this chart like I taught you how to do, whoops, I'm doing a great job with this pencil here. Okay, it kind of looks like this, okay? All right, that's not too bad. Um, they said we're keeping all the meters on this side of the chart. I had 17 meters, and they want to know how many centimeters is that? Well, we looked it up on our chart here, meters and centimeters. Okay, so I flip over to my chart. Okay, and right here it is. 1 meter is 100 centimeters. So you'll have this chart, by the way. You'll have a chart for your homework. So I put it on my chart. Keep the meter here. 1 meter is 100 centimeters. This says I'm supposed to multiply 100 times 17 is 1700 centimeters. And there's my answer. Okay? So that's how you would calculate to do the conversions. Now, this next example, number 3 here, is the same idea, but it's a little bit, we're going to set it up as a ratio, okay? If there are exactly 2.54 centimeters in 1 inch, okay? So I'm going to set up as a ratio here, inch. 1 inch equals 2.54 centimeters, okay? Then they want to know how many inches, so they're trying to ask for inches, are there in 5 centimeters? So they want to know how many inches are there. This is my X, okay, and this is my centimeters, in 5 centimeters. All right. So here's what you do, basically. There's kind of a couple ways to think of it. You cross multiply. If you cross multiply, you remember when we were trying to figure out ratio, like look at this, is 1/2 the same as 2/4? Okay, are they proportional? And we taught you that if you cross multiply and you get the same answer, yeah, 2 times 2 is 4, 1 times 4, they are proportional, okay? So they're asking you, are these proportional? Or they're setting it up as a proportion, okay? If there are 2.5 centimeters in 1 inch, how many inches are there in 5 centimeters? It's supposed to be proportional. So if I multiply 2.54 times x, cross multiplying, okay, and so 2.54 times x, and then I multiply, that equals 1 times 5 is 5. Now, in a very basic algebra class, there may be a few of you that recognize, oh yeah, I know how to do this. If I want to get x by itself, if it's multiplied by something, if I divide both sides by 2.54, and that'll give me the answer, okay? So basically, what you're doing is you're cross multiplying, and then you're just dividing 2.54 into this side. That would, if I put it as a fraction like this and do 2.54, okay, here, that would cancel it out, okay? So I would have x equals 5 divided by 2.54, okay? Which equals 1.968. And they ask you to round to the nearest, please underline this, okay, on your exam if you have this practice, to the nearest hundredth. This right here, guys, it goes like this. Look at my answer. Ones place, it's the 10th place, excuse me, it's after the decimal. 100th, 1000th. The next digit is an 8, so the 100th place goes up by 1. So 1.97 would be the rounded to the nearest 100th answer. Okay? Now, I know your brains are kind of spinning right now, but you'll have this to study, okay? When they set up a ratio like this, you can cross multiply and then divide to figure it out. All right. All right, now the next one, this is where I have to apologize to you because it says using figure 2, okay, by what percent did the home prices in King County increase from the year 2000 to 2005? All right, so, and here's the problem. The chart that I actually sent you on email, this is figure 2 right here, and it is not exactly the same chart that matches with the question I have you. It's the same type of chart, houses and housing prices, but the numbers here don't line up exactly, okay? But let me just show you, like if they ask you in 1985, if you started in 1985 with the price of houses, here's the year 1985. If the price was 120, this is median price of home, $125 in the thousands. So this is $125,000. Okay, in 1985, it looks like it's about 120, maybe 130,000, about 130,000. So I'm going to write this in here, 130, uno, dos, tres. Okay, 130,000. That would be 1985. So that's just kind of how to read that chart, just so you kind of see that. If you looked at the year 1998, it looks like the average house median, okay, average, is around $250,000. Okay, so from 85, when it was 130, to 98, to where it's 250,000 approximately, you see how much is going up. Okay. All right. So that's the basic, that's how to read the chart. Okay. Year it is and how much in thousands it costs for a house. Now, what I'm going to do is I'm just going to tell you how to do the problem, because the chart I actually did ask for, I'm trying to get you the right chart that goes with this practice exam. But here's what it would have looked like on the correct chart, okay? So using figure 2, I'm going to hit my focus button here for a second. It asks me, by what percent did the home prices in King County, they want to know the percent change. How much did it increase? They want to know by what percent, okay? They don't want to know the cost. They want to know the percent of the change. So how much did it increase from the year 2000 to 2005? All right. On the chart, I'm just going to tell you, okay, the starting value in the year 2000, okay, this was our starting value. It was $300,000 on the correct chart, okay? If you looked at the chart, it would be 300,000 in the year 2000, okay? The year 2005, 5 years later, okay, this is my final value. All right, it was $450,000 for a house, okay? Well, and they're asking you for the percent change. Right here on my notes, I wrote this down, and you might want to put this in your notes. You have it also in your own notes, but right on the test is helpful. The percent change formula, because they're asking for what's the percent of change, okay, is this. You take the final value, this is the 2005 value of the house, or whatever the number happens to be, minus the starting value. This is the starting value. We started with $300,000 houses, okay? And you take that answer and you divide it by the original value or the starting value, okay? So if I started with $300,000 houses and in 2005 they're $450,000 houses, I subtract those two, there's a $150,000 difference. That's my difference, okay, is 150,000, to use my bad French accent. All right, take that answer and divide it by my original starting value. That gives me, it would probably give you like 0.50, okay, something like that, okay, on a calculator. That is, changing a decimal to a percent, that is 50%. The question again asks, by what percent did the homes prices increase in King County increase? They increased it 50%. They went up 50%. And that's how I would calculate that. So I left this here, and I will apologize for the third time that the chart isn't exactly the right one. I will try to send you one. All right, I'm going to move on, guys, because I want to try to get you out of here somewhere close to, yeah, it's 8 o'clock already. I knew tonight was going to be long. I apologize. All right, so I'll speed things up a little. Using your answer for question 4, that's the last one we did, forecast the house prices in 2010 to the nearest $1,000. Here's kind of what that's asking. I'll show you, okay, from the chart that is not the same chart, but it is kind of similar. What it'll be actually showing you is that, you know, from about this year to this year, 5 years, 2000 to 2005, it went up 50%. And so it's asking, what about the year 2010? You see, that's another 5 years. Well, if it went up 50% in 5 years here, Another 5 years, we're going to assume that it's going to go up 50%, okay, in this kind of growth. So 2000 to 2005 in the last question, it goes up 50%. What about 2010? We can kind of extrapolate or guess that it would look like this right here. Where is it at here? Yeah, we from 2005, I'm going to write this, and you can write this on your notes here. 2005. I'm going to write year. Okay. And then they want to know what is it going to be in the year 2010? Okay. Well, if I take $450,000 houses times, this is 50% right here, that gives me 675,000. So we're saying, using your answer for question 4, forecast the house price. They want to know the price here. They don't want to know percent change. It would be $675,000. Okay. All right, moving on here, guys. Using figure 2, by what percent did the home prices in King County increase from 70s to 2000? This is the same thing, so I'm not going to go over this. This is the same formula. You start with your ending value minus your starting value. You get an answer. You divide that answer by your starting value. In this case of my numbers here, it's 1, so that's 100% growth. Okay. All right, same kind of problem, moving on, okay? This is the same problem here, so I can go through this kind of quickly. A dentist starts the year with 110 clients. That's his starting value. At the end of the year, she has 150 clients. By what percent, they want to know the percent, did her client base increase? Round to the nearest tenth. Notice I'm underlining this, okay, and modeling this, okay? All right, ending value 150. That's how many she had by the end, okay? She had 150 here. Minus the starting value, which she started with 110 clients, okay? That equals 40. It changed by 40. Divided by my starting value again, which is my 110 clients, equals 0.40. That's a 40% change. All right, we've done 2 or 3 of those. We're moving on here. This is the same thing. Oliver and Jamie were working together to lose weight. After the first month, they weighed in and compared their results. Fill in the table around to the percent in the nearest tenth. I'm going to circle this, nearest tenth. They want answers to the nearest tenth. All right, so what they gave you, what you're going to see on the exam, is you're going to see that Oliver weighed 280 pounds at the start. This is kind of his starting weight. I apologize that this kind of went off kilter here. And Jamie weighed 190, okay? Their ending weight, okay, at the end of their, this thing, Oliver weighed 244 and Jamie weighed 175. Now, we gave that, it's not going to give you anything else, but we're supposed to figure out their percent of weight loss. Well, if we take Oliver, he started with 280 and got 244. If I subtract these two, okay, subtract, you get, this is the difference right here, 36. He lost 36 pounds. Jamie started with 190. She went down to 175. She lost 15 pounds. Now, by what percent? So if I figure out what's the percent change, I take the ending value minus the starting value, okay? And I got 36. And if I divided that by the starting value, which is 280, okay, it would give me 0.129, which is 12.9%. Same formula with Jamie. She starts with 190, she ends with this. If I subtract these two, there's a 15 difference. If I divide 15 by, I'll write it in my notes, 15 divided by her starting value, which is 190, equals, it would be, it'd be 0.079, which changed to a percent is 7.9%. Okay, all right. That's how you would calculate those. All right, these ones are gonna go a little faster. Identify the factors. They wanna know the factors, and you remember factors are in like the number 6. Its factors are 3 times 2 and 6 times 1. Those are the factors. Those are things multiplied. When you have x's and y's, like 7y, which we have here, those two are times each other. They're right next to each other, so they're factors. Okay, each one of them is. Okay, so um, they want to know. They're looking at this right here. Okay, and they want to know what are the factors. Okay, I'm going to look at it, and I've got negative 7y. Okay, these two are multiplied by each other, and 2 is not a factor because it's added. And then I got 3 and y. Those two are multiplied by each other. They're factors now. Plus 4. 4 is not a factor. Okay, so my factors are negative 7 and y and 3 and y. Those are all the factors. Now you could have just said negative 7 y and 3 because there's kind of two y's here, but all of the factors are, if you listed it like this in your answer, I'd give you credit for it. Or if you just said negative 7 comma y comma and 3, technically those are the factors. Okay, all right, moving on to the next thing. We talked about expressions and equations, and here they're asking you, identify the expressions. Now, I kind of compared it to an expressions like a phrase. Okay, it's like half of a sentence. Okay, and so these are the two expressions right here. That's an expression, and this is an expression. Everything on that side is an expression. So the expressions are negative 7y plus 2. That's one of them. And a second one is 3y plus 4. Those are my two expressions. Okay. So they're like a phrase. They're not a complete sentence. A complete sentence has the equal sign in it. Okay. All right. And you have the answers there already. So identify the specific type of polynomial. You'll notice a week or so ago we talked about, I think it was last week, polynomials. Okay. And this has 3 different terms in it. Okay. So it's a trinomial. This has only one term. This type of polynomial, it only has one term. So it's a monomial. Mono means one. And this has 2 terms. They're separated by a plus or a minus. Okay. So it's a binomial. Okay. So you can look at your notes to review that concept, but you have those notes. All right. Now, type of reasoning. We went over this last week. 2 types of reasoning, deductive and inductive. When we generalize and move, I'm going to underline this word, we're moving from the specific details, okay, all these little specific details here, okay, that are happening, up to, it says, in specific case, to a general one. We're moving up to a general point here, to one point here, my pyramid here, okay. What type of process is that called? That's called inductive, where you start from the details and work up to the general principle. You're inductive. You're kind of moving up into it. If I started from the specific principle, the general principle, and move down to the details, I'm deducting down to the details. Okay, so that's the type of reasoning. All right, now we're getting into the formulas we just started talking about in the last 2 weeks. Okay. Consider this sequence. Oh, they use the word sequence. Okay, we learned about 2 kinds of sequences. We learned about arithmetic last week, and we learned about what was the other one? A geometric. And we learned that in an arithmetic, you add or subtract the same number each time. Very similar to what we just talked about. In a geometric sequence, we multiply. Okay. So what is the formula for finding the nth term? We talked about this last week, like the 4th month or the 6th month or the 19th month's nth term. So I'm looking at my numbers, my sequence. I got negative 15. If I add 3 to that, I get negative 12. If I add 3 to that, I get negative 9. If I add 3 to that, I get negative 6. It looks like I'm adding 3 each time. That is the number I'm adding. I'm adding the same number, okay? So this is an arithmetic sequence, okay? And it wants to know, what is the formula for finding the nth term, okay? And I told you that your formula for a arithmetic sequence is okay? Um, it's your starting value plus or minus. In this case, we're adding. And then I said your plus n minus 1. N is the term, minus 1 times however much we're adding each time, okay? They call this the rate of change. Okay. So that's my rate of change. That is my formula for arithmetic growth here. That is the formula. All right. So I'm going to use that formula because it asks you what's the formula for finding the nth term. Now, see, nth means they're not telling you which term it is. Okay, they're just saying if it was n. Okay, you would start with a starting value. Well, my first starting value is 15. There's my starting value, negative 15. Excuse me, negative 15 plus. Okay, because it's arithmetic growth, same number. N. See, it said for the nth term here. Okay. It could have said 6th term or 11th term or 10th term, but it just says nth term. So I'm going to put that n in here, minus 1, that's my formula, n minus 1, times my rate of change. We said it changes by 3 each time. Notice I'm multiplying by a positive 3 because I'm adding 3 to these negative numbers and they're getting bigger. That would be my formula. And that is the formula for, that is the arithmetic growth formula. All right, then it says, using the nth terms in question 13, what is the value of the 12th term? So what they're saying here is, do you see how I have term 1? This is n1, n2, n3, n4. But what about the 12th term out here somewhere, way out here? What would the value be? Okay. I'm going to plug that 12th, that n is now 12. I'm going to plug it into my formula. So here it goes. Here's my start value is negative 15 plus, here's my n. This is my nth term here, okay? My n is 12. They ask you for the 12th term. That's my term, okay? Minus 1 times 3, okay? So that equals negative 15 start value. 12 minus 1 is 11. Times 3 is 33. So that gives me negative 15 plus 33. When we add a negative and a positive together, you subtract and keep the value of the larger number. In this case, it's a positive 18 because the larger number is a positive. So that's my answer is 18, okay? That's how you do that one. And you have it right there in your notes. You have the answer there, so you can just study it. And you'll also have this recording if you want to listen to it again before you take the final exam. I started recording at about 20 minutes to 8, so it'll be about a 45-minute recording. 15, identify the following sequence as either, so they're telling you it's one or the other. It's either arithmetic, or is it geometric, or is it neither, okay? All right, well, you can see the answer is geometric, but let's look at how we would figure this out if this was blank here. We'd go, okay, from 5 to 10, we added 5. That means if it's arithmetic growth, we would add 5 to the next one, and next one would be 15. We'd add 5 to that, this next one would be 20. That's not what's going on here. We went from 5 to 10. Well, that's doubling it. Did we double it again? Yeah, 10 times 2 is 20, 20 times 2 is 40. This is geometric growth here. My multiplier is 2, okay? We're multiplying. And we already said in our notes tonight that when you're multiplying, there's geometric and exponential growth. All right, then you're gonna get a table like this. In the following table, compute the y value, okay, for a given x value, and it tells you what you're supposed to do. They want you start with an x value by multiplying the x value by 3. So here's what your chart would look like. I'm going to cover it up. Your chart would look like this on the quiz, on the test, excuse me. You would have a y and an x. They would give you all the x values, and then you would start with 0, and then everything else is going to be blank. And so you got to figure, okay, if the question says that I gotta multiply the x value by 3, well, x times 3 is 0. 1, that's my x value, times 3, because it just said right here at the top, it said that's what I'm supposed to do every time. X value, 1, times 3 is 3. X value, 2, times 3 is 6. 3 times 3 is 9, etc. Okay, so we are multiplying by the same number each time. Okay, and that's how you would fill in these numbers on your test if I did something. Now, probably what I did, knowing me, trying to be smart, I probably would ask you for what would be the third x value. I would just ask you for 1. Um, yeah, I changed this so it asks you just for one of these. Okay, all right. Or I changed it and made it even simpler than that. All right, in the following table, compute means calculate or find the answer, a y value by, here's how, multiply each previous y by the value of y value by 4. So, um, so let's see here. Let's see. If I take the previous value, so I've got the previous y value, you'll notice here, look at this carefully. It's asking you to take the previous y value. That's really important. You're not confusing it. It's not asking you to multiply by the x value. It's asking you to multiply the previous y value by 4. So 1 times 4 is 4. 4 times 4, this is the y value here. Okay, again, we're talking about the y here. Draw my arrow here. Times 4 is 16. Each time I get these answers by multiplying by 4. What you'll see on your test is this right here. You'll see all these things if I had this kind of problem, but you wouldn't see the answers. You would figure it out by multiplying the y's by 4. All right. Using questions 16 and 17 to write a function. This is a formula. This word function means they want you to write the formula. Okay. They want the formula to model the data and whether the function is linear or exponential. All right, so in this case, in number 16, okay, they even gave it to you. They said, compute the y value for a given x value by multiply the x value by 3. So y equals 3 times x. Okay, that's the formula of it. Okay, we're multiplying by the same thing, so it would look like this. I gave you the answer here, so you can kind of study it. That's a function for it, and they want to know, is this linear or is it exponential? Well, I could look right up at my chart and go, it's changed by 3. It changed by 3 every time. It's exactly adding 3 each time, and we know that's the definition of linear growth. So we write it's linear growth. Okay. The function for this one over here, this one right here, it said by multiplying the previous y value by 4. So really, y equals the previous value by 4. So our multiplier, we're multiplying times 4 each time here. Okay, that's our multiplier. So the function would be, we just talked about this in tonight's notes for exponential growth. It's the multiplier to the whatever term this is, to the first or a second or third or fourth, whatever term we're trying to find out here. So to the x, these are the x's right here. So the exponent is the x, whatever year or month or whatever it happens to be. That's the function. That's the formula for this one right here. It spells it out for you here. We're just putting it into a formula. Okay. Now, if you were thinking, but teacher, didn't we have more steps in the formula than you're showing us right here? This looks like this little answer right here. If I circle it here, this looks like it's skipping some steps. Technically, it kind of is. So you could have written it like this. Y equals the starting value. Here's my starting value times the multiplier. This is the formula I just gave you. Okay. To the X, whichever term it is, okay? And that's exponential growth. All right, last question or so here, okay? A company has 1,200 clients and wants to gain 15% more of clients each year or each quarter in this case, each quarter, okay? Use your calculator to complete the table, round your values to the nearest whole number, okay? So here's what they're gonna give you on the test. They're gonna give you this. They're gonna give you quarter, this Q is quarter zero, then after the first quarter, and second quarter, third quarter, they're gonna give you this, and they're gonna give you a starting value of $1,200 or 1,200 clients, excuse me, okay? And they're gonna wanna know, okay, after one quarter, how many clients? Well, if I take, it's 15% more. If I take here's the fast way to do it, 1,200 times 1.15, okay, that's 115%. I should write it like times like this. If I take 1,200 times 1.15, that will give me this answer right here, 1,380, okay? But they want to know, okay, well, how about after 2 quarters? Now, this is really important. I got to take the new answer. I'm pausing for emphasis here. New answer here, 1,380 clients. I got to take that 1,380 times 1.15. Okay, that will give me 1,587 clients. I got to take that new answer, 1,587, and multiply it times 1.15. And I'll keep doing that to fill it out after 5 quarters, okay? All right. That's the fastest way to figure out that one right there. And I might just ask you, but anyway, that's the quick way to do something like this, okay? The slower way is if I took 15% and just multiplied 0.15 times this, I'd get an answer. And then I'd have to add the answer to 1,200 to get to this, if I did it that way. All right. All right, last question. And this one's going to involve you guys using the formula that we just got through talking about. It says, the function that models the data in question 19, okay, they want to know what would be the function of this. It actually gave it to you. The term, okay, so let me go back to the T here. They used a T here. So here, the reason why they're choosing a T is total clients, T. See how it used a T right here? Okay, so that's how many clients there were, T. So that's why all of a sudden the letter changed on you, so you won't get confused. The T right here, the total clients equals my starting value, 1,200 clients, times, that little star there means times, the rate of change, and we just got through talking about this, it was 1.15 to that Q there, the little Q is the quarter. Okay, so is it the first quarter, the second quarter, the third quarter? All right, using this formula or function, how many quarters will it take to surpass the company's goal of 1,500 or 4,500 clients? Okay, so here's what you could do. I'm going to show you how I would do it if I was taking this test. They want to know how many quarters will it take to surpass the company's goal? Well, if I look back at what I was just doing, it said after, because it wants us to get to 4,500, right? It wants to know. In the last problem, after 5 quarters, I had 2,414 clients after 5 quarters. So I'm guessing and I got to get to 4,000 something clients. Can you kind of think with me here out loud here a little bit? After 5 quarters, I got 2,400. How much is it going to take? How many quarters is it going to take me to get to 4,000? Twice this much, right? I'm going to guess around 10 quarters. Doubling this gets me close to 4,000 something, right? So that's how come in my notes here for you, just thinking out loud. If I said, well, let's try 9 quarters, after 9 quarters. Starting value, $1,200, times my rate of change, 15%, growing by 15%, which is 1.15, times 9 quarters. That gives me 4,221 clients, but they want to know how many quarters is it going to take to get me 4,500. Well, if I plug in 10 here, after 10 quarters, there's my quarters there. I get 4,855 up. That's more than the amount. So after 10 quarters, I will have reached my goal of 4,500 clients. Okay. All right. That's a lot to think about. However, I think what I'm going to do is stop my recording